class. It's me, Professor B, and today we are going to go over Gaussian elimination with back substitution. Okay, so if you're talking about linear programming or matrices with elimination, there are two types. We've got Gaussian elimination and we've got Gauss-Jordan elimination. So we're going to do two videos, one on each. If you've got questions, you want to see different examples or specific examples, just leave a comment and I will work on them for you, okay? So let's get started. So the first thing that I am going to mention to you is there will be no spicy, medium, mild. All of these are pretty much medium to spicy because of the details, all right? The operations themselves are not difficult. It's multiplication and addition mostly. So those are not very difficult, but the process can be a little bit daunting when you are having to just maintain everything. As long as you go slow and pay attention to what you're doing, use a calculator when you need it, you're going to be just fine. Okay. So for Gaussian elimination, we are going to look for this kind of a matrix in the end. All right. So we're going to have ones going down the diagonal, zeros underneath, and then all of these are just random numbers. Okay. After all the processes we've done. So this is called row echelon form. Your calculator can do this, but in most cases, you're going to have to know how to do it by hand as well. So here we go. The first thing that we're going to do, notice we have three equations, three different variables. What we're going to do is we are going to convert this system to a matrix, to an augmented matrix. Okay, so the way we're going to do that is we are just going to take the coefficients of each. So we're going to have a column of x's, a column of y's, a column of z's, and a column of answers. Okay, so when I do this, I'm going to end up with -2, 3, 3, -1, 4, 6, -1, 1, 5, and I'm going to put a line here, -11, 19, 43. So this is our augmented matrix that we are going to start from, okay? If you are needing dimensions of this matrix, remember dimensions are always rows by columns. So we have 1, 2, 3 rows by 1, 2, 3, 4 columns. So this is a 3 by 4 matrix. That's especially important if you are going to use your calculator for this. Okay, so we are going to go in a very specific order. All right, I'm going to come over here and I'm going to show you. So remember, this is what we want to look like in the end, but the way we get there is an important order. Okay, so this guy is going to go first. We have to get him first, and then we're going to get the zeros underneath. Then we have to find the 1 in the next column. So this guy will go fourth, and then the 0 underneath. And then we will get the 1 in that third column, okay? So we have to go in this order to make sure that everything works out, all right? So that just gives you a little roadmap of what we're doing. So when I come over here, the first thing that I want to do is I want to make this guy become a 1. All right. There are three ways to do row operations in matrices. You can multiply or divide by a number. You can switch rows. So I could switch rows this way. Or you can multiply and then add to another row. Okay. So those are the only three operations we can do. So that's what we're going to do here. I am going to take -2. Remember, we want it to become a 1. So I am going to do the row operation -1/2 times row 1, and that's going to give me my new row 1. If I multiply -2 by -1/2, I'm going to get a positive 1, and that's what I want. Okay, we don't care what the numbers come out to be on the other side. We just care about the one number that's circled. All right, So when we do that, I'm going to show you the row operations over here so you can see what I'm doing. This is going to be -1/2 times -2. And then the next column, -1/2 times -1. And this is a row operation, so we're doing this in the row. And then we're going to have -1/2 times -1 again. And then we're going to do -1/2 times the -11. If you get fractions or decimals, don't freak out. That's perfectly acceptable. I recommend you keep it as fractions just so you're not having to write a whole bunch of decimals, but up to you. Okay, so these are the operations that I'm going to do on the first row. The second two rows are going to stay as they are. So I'm going to end up with -2 times -1/2 is 1. -1/2 times -1 is a positive 1/2. -1/2 times -1 is a positive 1/2. And -1/2 times a -11 is a positive 11 over 2. Again, I'm going to keep everything as fractions. So when I write my matrix, my new matrix, now I'm going to have 1, 1/2, 1/2, far down, and 11 over 2. And then my other matrices just get to, or my other rows, I apologize, get to just stay the same. 3, 6, 5, 43. So this is my new matrix now. Okay, so now we're going to take this matrix and we are going to, if you remember the roadmap means this guy now has to become a 0. All right. The easiest way to make your numbers become zeros is to multiply the row with a 1 in it. So we're going to multiply this row by the opposite of what you want to become 0. So we want a 3 to become a 0. So we're going to multiply by a -3. And we're going to multiply it by the row that has the 1 in it. And then we're going to add it to the row that we're trying to make a 0. We're trying to make row 2 a 0. And this is all going to be my new row 2. Okay, this is a pattern that we're going to repeat a lot. All right, so again, you're multiplying the row with a 1 in it by the opposite of the number you want to become a 0. I want the 3 to become a 0, that spot. So I'm going to multiply by -3 times the row with the 1, and then I'm going to add it to the row that I'm trying to make a 0. I'm trying to make this 3 a 0, so that's in row 2, and this is going to be my new row 2. All right, so rows 1 and 3 are going to stay perfectly the same. Do the same thing. I'm going to show you my operations. So this is going to be -3 times 1 plus a -3. I'm sorry, a positive 3. Sorry, watch your signs. Then I'm going to do -3 times 1/2 plus 4. Then I'm going to do -3 times 1/2 again, just going down the row, plus 1. And last but not least, I have to do my answers. So I will do -3 times 11/2 plus 19. Okay, so those are my operations I'm going to do. All right. So before I do those, I'm going to go ahead and copy. Remember I said rows 1 and 3 are going to stay the same. So I like to just go ahead and copy those just to make sure I don't forget anything. So 1/2, this is going to be 5. Draw my line down. And I have 11/2 and 43. Okay, so when I perform my row operations, -3 times 1 plus 3, that's going to give me a 0. -3 times 1/2 plus 4 is going to give me 5 halves. Again, I'm leaving as a fraction. Negative 3 times 1/2 plus 1 is going to give me negative 1/2. And negative 3 times 11 halves plus 19 is going to give me 5 halves. So this is my new row 2. Again, you can use your calculator on each one of these 4 calculations. Don't be afraid of that. All right. So I am going to end up with 0, 5 halves, negative 1/2, and 5 halves. Okay. So we got that 1, 0, remember? So we got the 1, we got the 0. We're going to go down the column. We have to make this guy become a 0. So we are going to do the same thing that we just did. We are going to multiply. This is what we want to be a 0. We are going to multiply the row with the 1 by the opposite. So negative 3, row 1 again. Plus, this time we're trying to make the number in the third row become the 0. So we're going to add that to our row 3, and that's going to be our new row 3. Okay? So again, going over those steps, the number that you want to be a 0, you're going to multiply the opposite. So that just means change the sign. So if it's positive, you're going to multiply by a negative. If it's negative, you're going to multiply by a positive. So negative 3 times the row with the 1 in it. This is the row with the 1 in it. So negative 3 times row 1. Then add that to the row that you want to be a 0. We want this guy to be a 0. He's in the third row. So I'm going to multiply him or add him to row 3. And that becomes my new row 3. So the operations for you are going to look like this. They will be negative 3 times 1 plus 3. Then we're going to have negative 3 times 1/2 plus 6. Then we're going to have negative 3 times 1/2 again plus 5. And lastly, we are going to have negative 3 times 11 halves plus 43. This is also not the end all be all of this is the only way to do this problem. There are multiple ways to do it. I just find going into a routine and going, okay, I know I have to, in order to get the 1, I do this. In order to get the 0s, I do this. I think just having that routine makes it a little less spicy in the end. Okay, so we are going to have first and second rows stay the same. So I'm just going to copy those. That would be 1 and a 0, 1/2, and 5 halves, 1/2 and negative 1/2, 11 halves and 5 halves. Okay, so to do my math on the other ones, negative 3 times 1 plus 3 is 0. Negative 3 times 1/2 plus 6 is 9 halves. Negative 3 times 1/2 plus 5 is 7 halves. And negative 3 times 11 halves plus 43 is 53 halves. So this is my new row 3. Okay, so I'm just going to copy that. I have a 0, 9 halves, 7 halves, and 53 halves. Okay, and then we are done with our first column. Okay, we have 1, 0, 0. So the next thing that we want to do now is we want to make this guy become a 1. All right, remember we said there'd be 1, 2, 3, 4, 5, 6. Okay, we're going in that order. So we need this guy to become a 1. So if I come back here and I show you, remember when we wanted this guy to be a 1, we multiplied by the reciprocal. So the reciprocal of negative 2 is negative 1/2. We multiply by reciprocal and you get your new 1. Okay? So I am going to do the row operation. 2/5, that's the reciprocal of 5/2, times row 2. And that's going to be my new row 2. So rows 1 and 3 are going to stay the same. So I'm going to do 2/5 times 0. This is also why we do this, because look, so even though I multiplied this guy by a number, he's still going to say 0, and that's what we want. Okay? Then I will do 2/5 times 5/2. Then I will do 2/5 times negative 1/2. And then I will do 2/5 times 5/2 again. Okay, so that's the arithmetic that I'm going to do for my second row. First row is going to stay completely the same. So I'm going to copy those. I have a 1 and a 0. I have 1/2 and 9/2. I have 1/2, 7/2. And then I have 11/2 and 53/2. So those stayed the same. For my second row, 2/5 times 0 is 0. 2/5 times 5/2 is 1. 2/5 times negative 1/2 is negative 1/5. Still have a fraction, that's okay. 2/5 times 5/2 is 1. Okay, so that's my new row 2. Copy that, 0, 1, negative 1/5, and 1. Okay, so we're getting closer. Again, it's a lot of just being careful, repeating what you're doing. So I think writing it out definitely helps. So the next thing that we need this guy to become a 0 now. All right, so remember that means we are going to multiply the row with the 1. So that would be this row in this case, the second row, by the opposite of what we want to be a 0. We want 9/2 to be a 0. So I'm going to multiply it by negative 9/2 times row 2 plus row 3. That's going to be my new row 3. Okay, because that way when I do negative 9/2 times 1 plus 9/2, that gives me a 0. We don't worry too much about what the numbers become over here. And these will end up staying zeros because of the way we've done it. So for my operations, I'm going to have negative 9/2 times 0 plus 0. Then we will have negative 9/2 times 1 plus 9/2. Then we will have negative 9/2 times negative 1/5 plus 7/2. And lastly, we will have negative 9/2 times 1 plus 53/2. Okay, that's my arithmetic for my third row. Rows 1 and 2 stay the same, so I'm just going to copy them. I have a 1 and a 0. I have a 1/2, 1. I have a 1/2 and a negative 1/5. And I have a 11/2 and a 1. Okay, so for my third row, I'm going to have negative 9/2 times 0 plus 0 is 0. Negative 9 halves times 1 plus 9 halves is a 0 as well. I will have a negative 9 halves times negative 1/5 plus 7 halves. That ends up being 22 fifths. And then I have a negative 9 halves times 1 plus 53 halves is equal to 22. Okay, so that's my new row 3. So I've got 0, 0, 22 over 5, and 22. And look what's happened because of the way we've done this and the order that we've done these things. The first column has stayed exactly the way we wanted it. It's 1, 0, 0. The second column is now exactly the way we want it. It is a number and then 1 and 0. And then all we have to do now is change this guy right here to be a 1. And then we will be done with the row operation portion of the Gaussian method. Okay, so remember, to make a 1, you're just going to multiply by the reciprocal. You're going to flip the fraction and multiply it. So this guy is going to become 5 over 22 times row 3 equals my new row 3. So we're going to have 5 over 22 times 0. And then we are going to have 5 over 22 times 0. And then we're going to have 5 over 22 times 22 over 5. And last but not least, we are going to have 5 over 22 times 22. Okay. So first two rows stay the same, just like they have been. So I will get 1, 0, 1/2, 1, 1/2, negative 1/5, bar 11 halves 1. And then my new row 3 will look like 5 over 22 times 0 is 0. 5 over 22 times 0 is 0. 5 over 22 times 22 over 5 is 1. And 5 over 22 times 22 is 5. Okay, so my new row will be 0, 0, 1, 5. And I am done with the row operation portion of this problem. I'm not all the way done, but I am done with that portion. We have 1, 0, 0, 1, 0, 1. So if we go back up here to what our picture was supposed to look like in the end, remember I said we'd have 1, 0, 0, 1, 0, 1, and then these would just all be other numbers. We are in that form, so we are done with that portion. Okay, so the next step of this is we're going to put this back into the system form that we had earlier with the x's, the y's, the z's, and the equal sign. Okay, remember that this is just by column, so this is my x column, this is my y column, this is my z column, and these are my answers. So you could almost put like imaginary little equal signs each here. Okay, so when I rewrite this, it will end up being 1x plus 1/2 y plus 1/2 z equals 11 halves. So that is this first row. I just put an x, a y, a z, and the equal sign. For the second row, I'm going to have 0x plus 1y minus 1/5 z equals 1. That's my second row. My third row would end up being 0x plus 0y plus 1z equals 5. So this is my new system after all of my row operations. Okay? So I'm going to take this and move it down here so I've got a little bit more room to work. All right, so I'm here. All right, and now we're going to solve for x, y, and z. So when we're done with this whole problem, we're going to have an x, comma, a y, comma, and a z, comma, and a z. Sorry, no comma. All right, so x, y, z. So if I were to clean up these guys, look what happens. I have 0x. Well, that's just 0. So this equation is really just y minus 1/5 z equals 1. And then the one below it is 0x plus 0y, that's just 0, plus z equals 5. So if you look at that bottom row, we already know what our z value is. It equals 5. 1z equals 5. Awesome. So we already have 1/3. Now all we're going to do is we're going to go backwards and we're going to fill in this z value into this second equation here and solve for y. So I'm going to do y minus 1/5 times z, but we already know z is 5, equals 1. Well, 1/5 times 5, negative 1/5 times 5 is a negative 1, so this is really y minus 1 equals 1. And this should be a plus sign. Sorry, went crazy for a second. So plus, no, I have that right. Sorry, ignore me. So this is negative 1. We're going to add 1 to both sides. This is why you have to pay big attention to what you're doing, making sure we get this right. So when I do that, I end up with y equals 2. So that's my y value. My y equals 2. Awesome. So now all we have to do is we're going to take our z and our y. We're going to plug it into the top equation now and solve for our x. So we will end up with x, come up here a little more room, x plus 1/2 times my y value, which is a 2, plus 1/2 times my z value, which is a 5, equals 11 halves. Okay, I'm going to clean all this up, so I end up with x 1/2 plus 2 or times 2 is plus 1. 1/2 times 5 is a plus 5 halves, and that equals 11 halves. Okay, 1, if I'm collecting my like terms to just solve for x, 1 plus 5 halves is equal to 7 halves. So I have x plus 7 halves equals 11 halves. And then I'm going to subtract 7 halves from both sides. That one goes away. And I'm left with x equals 11 minus 7 is 4 over 2, which we can simplify to just be a 2. So there's my last value. Okay, so this is our ending solution. Remember, this is just like solving systems of equations. Okay, we're just using linear programming, Gaussian method in order to do that. But this is another way of solving systems of equations like we've done in previous videos with the substitution and elimination method. So 225 is my solution. If we wanted to, we could climb all the way back up here. We could plug in a 2 for the x, a 2 for the y, and a 5 for the z, and then see if it ends up being negative 11 or 19 or 43 in each one of these equations to check. Okay, so that is it for that Gaussian elimination. Again, they're all kind of medium to spicy because you just have to pay attention to what you're doing. If you guys need more specific examples or you want another example, just let me know. And that's it for today. If you've got more questions, let me know. I'll leave a comment, like, subscribe, help me out, and I will see you guys next time in class. Bye.